Bonjour and hello. And wouldn't it be great if when I go to work, I could just ask Claude to do almost everything for me? Just analyze my production system, just go and find the critical problems, determine the root causes, implement them, ship them for me to production. This is what everyone wants. Spoiler, doesn't work. I work for Anthropic. I can tell you that it doesn't do my job. But some bits from that are starting to move fast enough and are starting to be part of reality. Now, I think you might be curious to know what's real versus what's hype. And we'll be going through that. Oh, and for the PS about that tungsten cube. Well, it turns out that Claude's vending machine did everything to bring it after I reminded it. It's here in my pocket. Tungsten is one of the metals that's very heavy. So while the cube looks small, if I drop it, it might make a hole. Now, I'll start with explaining the current stage and how I understand it. Then I'll talk about production engineering and other names that we get to call my industry. Then I'll give an example of current AI model capabilities which are able to get into an agentic loop and fix parts of my day-to-day work. And finally, I'll end with a comparison with another industry that had to go through this change, which is self-driving cars. About me, I'm one of the first two people who joined Anthropic in London. I did on-call for the serving stack to learn in the first 3 months about how to run Claude in production. I then helped onboard my teammates, so I would not be stuck on call my entire career. And now I'm trying to improve the system so it goes down less. Previously, I was a member, I was an SRE at Google, specifically on the Google Cloud's compute offering. You might know our competitors as AWS EC2 or Azure virtual machines. And I was a member of the SRE for SRE team at Google. Google grew so big that it needed another level of escalation. And one of my favorite incidents, and if some of you were using Google Cloud in April 2023, was that not very far away from here, there was a data center in Paris that had a water intrusion. And my pager woke me up, and I'll always remember Paris for that incident, and I'll always remember all my customers that were surprised. Now, what I think about you, I don't know you, but I can imagine. I think you care about reliability. I think you think it's the #1 feature, because if the product is down, none of the other products work. I also think you're excited, but also nervous or uncertain about the AI and agents. You've got ideas, but it's hard to separate the hype from the reality. And right now, AI dominates all our conversation, so you're just trying to balance it will solve everything with what can it actually do today? How can it help? And the world is objectively experiencing massive model advances. All the apps, being Anthropic, OpenAI, Google, even the Chinese ones like Alibaba. We heard recently about Quinn. It's a very good model. DeepSeek was all the rage in January, February. All are shipping improvements that are better than the previous generation every 3 months or so. And you don't have to look back very far away, like 2 years ago. What were the models able to do? Not much of what we're able to do now. And yeah, there's a lot of hype, but also there is change that's happening upon us. We spend a lot of time talking about hallucinations, but I think most of our time should be spent on what can it help us do today? Where are the places where I can work with the current capabilities. And building production software, building software that's ready for production using vibe coding, that's 100% not there. I'm not here to lie to you and to tell you that you'll just be able to ship to production everything. But vibe coding for prototypes and building internal tools and throwing them away and running fast data analysis just with the natural language, just with speaking to, talking to your database, those things are here. I've been able to do it. Some of you have been able to do it. Your colleagues have been able to do it. And they are changing the way we've been doing things in our industry. The changes of who can do software and how much software do we have to run are also upon us. And we, collectively, will have to deal with it. Now, this is my part of the industry, the production engineering, or SRE. My previous boss's boss quipped that SRE is what happens when you ask a software engineer how they would run an operations function. Now, Ben Traynor, when he quipped that, and he started it several years ago, I don't think people thought it would grow so big. I think people thought, oh, it's a niche thing. It's just for Google. But turns out other parts of the industry had the same problem. How do you run software reliable at scale? And many people have many different names now. Some call it platform engineering. Now it's reliability engineering, which is my title. Even when people talk about DevOps, they're talking about running software reliably. The basics are there. I won't go through them. There's the original SRE book. But even some people at Google view it aspirationally. Don't tell that secret. They might be mad at me. One of the misconceptions, though, that I see it all the time across the industry, that you can hire some people, maybe they previously did reliability, or they don't, and you just give them the reliability title. You put them in a corner, and they'll just sprinkle the reliability dust on everything. And suddenly, your system will have all the names your customer wants. If it doesn't, don't worry, I'll hire 2 more reliability people, and the system will become even more reliable and self-healing. That does not work. I hope we all agree with that. And reliability needs to be integrated across the entire organization. You wouldn't build a system from scratch and then give them to your security people and ask them, make this secure. Same principle. It's broad. It's everything that causes you pain. Your CI/CD pipeline, the quality of your testing, hiring, all process work. And also, SREs need to be creative. Like, if you hire an SRE team and they just sit there and say, no, we're not releasing, no, we're not doing that, it won't help the business. So as an SRE, you have to solve both for velocity for your business and for reliability. Now, this is where I think AI agents might come. But we've had this a bit previously. We did have vendors, we did have products telling us that it will solve reliability for us. Here are some things that we used to do before the LLM revolution, like unstructured data. There are some logs here, some traces there, some Slack discussions, scattered everywhere. And you had to write a report for an incident. There was systems that you could ingest all, and they'll give you a best effort, and then you provided that report. Anomaly detection, which is genuinely hard. And if someone tells you it's easy, they're probably wrong about it, because you need to nail the precision recall and the trade-offs. Otherwise, it will fire all the time, or it will never fire when you have a real issue. In natural language for data analysis, not everyone is fluent in SQL. And those of us that, even those of us that know SQL are confused about types of joins and subqueries. And this meant that we tried as much as possible to help our sales folk or our marketing folk to self-serve rather than fill tickets for engineering to get some data. Now, those technologies, unfortunately, work in very narrow contexts. Anomaly detection, only if your observability has good data. Logs analysis, only if your logging system has been fully denormalized. Root cause analysis, only when you have a structured incident management system. And capacity management and predictive management, only with your cloud provider or on your Kubernetes schedule. So these are point solutions for point problems. And this is simplistic. I mean, I want 2025. I want what was promised for me. I want to ask the robots to make it work, make it go pretty, so I can go and visit the beautiful city of Paris rather than spend my morning in another incident. And no, it doesn't work, but that does not mean in the future it won't work. Agents are one way. We're trying to build something that resembles this. MCP, I think, kickstarted this revolution because it's brilliantly simple. It's just the protocol. It almost does nothing, which is why it works. This is how people will integrate models and prompts and systems, and we'll have those multi-step agents going around our production. You'll help invent that. Your vendors will help invent that. We'll provide you the most intelligent models, and we'll have the MCP as the connectivity tissue for the starting point of this revolution. Now, it's early days. Of course, we don't have yet the capabilities for this. But we also haven't had time to work on all of these problems. MCP is barely a year old. Claude Code was released only in February. And Claude Agent SDK, which takes Claude Code and puts it into a reusable framework, that launched a month ago, and I'm not even sure if a lot of you know about it. But very many people are talking about it. You are here at an AI conference talking about these things. This is a signal that there is potential in the hype. And everything is moving fast. We're learning together about it. We're playing with proof of concepts. So let me try and help you find some use cases. And this is the sci-fi part. These are the speculative things. I don't know about everything. The future is hard to predict. And even also, it arrives unevenly. You can see it on the internet with people saying, AI doesn't help me, or other people saying, AI coding has changed the way I do my job entirely. When you get paged, the system tells you what it's likely wrong. Like, how many of you here have been paged and have been on call? Yeah, some hands up. I have a lot of empathy for you. You're disoriented. We were probably sleeping, and you spent 30 minutes bumbling through dashboards, trying to figure out what's happening. And if a system just showed you, here are 5 relevant graphs. Here are 5 graphs that have anomalies. There's a step function. Even if it's wrong sometimes, this will cut time from you having to identify them. Then consuming all the artifacts in Slack, in docs, in dashboards, and filling in the template, there are vendors, just like I told you, that do this, but LLMs actually understand in depth the issues. They know 2 hours of a 0.5% error rate incident is way less important than 10 minutes of an 100% error incident. And let's say you're ambitious. You wrote 50 action items. You promised yourself the incident will never happen again. But 2 months later, the business priorities have changed, and your boss is telling you, you need to ship more of these features, and the incident is in the past. How do you prioritize this? This is also a way where LLMs can be a force function to just tell you, these actually appeared in 2 other incidents, so I think you should do those. And the other 47 incidents, just wait until there are more people to help you. Now we're getting into medium difficulty things. Assess changes for likely disruption before they happen. Your agent has all the code, has previous versions, has historical alerts. It has the delta of where you're going. For a human, this would be a full-time job to just look at every commit and say how dangerous it is. But for an LLM, it will just consume the text and categorize it and tell you, hey, this database migration, it will log the user tables during signups, or this cache invalidation, you're going too fast. And for alerting, can we go for these are 5 graphs where I see changes to these is a story of 3 graphs where you go from a rollout to errors to maybe a button to roll back? I think so. I think we're close. And finally, do the introspection. Identify the reliability improvements. Where are the 2 components that have built separately, but now they need to be united? And this is the hard part. This is the scary part, depending on where you are in the career when I talk with people. For architecture and design, I think there are 2 trends here converging. There's AI agents doing actual software engineering. If we're not there today, we'll be somewhere in the future. And there's infrastructure as code, where you can, everything is declarative. There's no reason computers in the future can't architect, configure, design, write, and deploy their own compute. I think we're just arguing for timelines right now. And to be honest, I've never heard someone say they love working with Terraform and they wanted to spend more time on Terraform scripts. Death by YAML was no one's choice, yet here we are debugging 5,000 YAML files already written by robots. So let's get them to the robots directly. Change management, consume all changes. Deploy slower. Don't have a static deploy system. Have it move and change as you add new components. And for observability, why do we have to think beforehand? Why can't the code introspect itself? Now, I said we're not the first ones going through this. The Society for Automotive Engineers published this framework in 2014, over 10 years ago. As you go higher and higher in levels, more and more of the columns that what a car does get filled by systems rather than humans. Acceleration, braking, turning the steering wheel, having to deal with unexpected incidents like a car just is parked, and actually being able to drive not only in sunny California, but in the French Alps when it's snowing. All of this has been mapped by people who've been building cars for hundreds of years. Most modern cars are level 2. You have automated braking, you have some line following. Level 3 is where it gets interesting. This is Tesla in the US and BMW and Mercedes in Europe. But Waymo is stellar in level 4. It's already a beauty to be in a car in San Francisco when there's no one sitting in the driving seat. You can watch them cruise when no one's inside. How many of you have been in a Waymo? Not many. As I said, the future is not evenly distributed. And this is how it will feel for us with agents in production. Now, if we were to map this for production agents, we would have detection, who identifies something is wrong. We would have response, who does stopping the bleeding immediately, and we'll have the prevention, who does the deeper work to improve the system. The operational domain is also interesting because you could have an agent that's very good on your inventory system, but you can't parachute it to your external website. Or maybe you will at level 5. Now, if we look at most software, right now, I claim it sits at level 2. We have observability kind of fully automated. We don't need to play with it a lot. But let me show you glimpses of some level 3. Now, here's some code that I generated with Claude code. Here's the main function on line 24. At the bottom of it, you can see that it loads a user config. And I have put the line that has the bug where a type will be incorrect. Now, I run the code. I get a value error. And I'm sorry for you who are not familiar with Python, but this is how the language works. And it's wrong. And it could be wrong in my production. But if I copy and paste the error in a Claude code session and add a please fix it, Claude reads the file, and it's immediately recognizing it, the problem. Not only that, it suggests the code that I need to fix, and it finds the problem in a second place. I never saw it previously because it was all good there. This was not possible 2 years ago, and it only started possible with the current generation of frontier models. Now, what if we put this in a loop? And we're something at the very beginning, though. We have humans in the review, and the model proposes all the fixes for errors, but you wouldn't necessarily be able to remove all the humans. But this will be, I claim, what will get us to level 3, where agents are able to detect issues, where they understand what we need to do, where they can run some kubectl commands by themselves. And level 4, this is the Waymo moment. This is where they can do all the medium things that I was able to tell you. Now, level 5 is the endpoint. Agents handle everything. Humans are basically just production managers in the reliability org. And not only that, but you can parachute it to another system and another system, and we'll be able to do it. Are we here? Nowhere near close. And honestly, it might require AGI, which we don't know yet. But we're improving fast. This is a graph from Meter, which is an organization that evaluates AI capabilities. And you can see that on the y-axis, we have all the release models. And on the x-axis, you can see the autonomous duration of task that the model can do. I posit that the exponential trajectory there is being shown. And frankly, we're also aware of the AI scaling laws. We're building bigger data centers. We're having more compute. We're getting more data. And we might go way faster than some people expect in the harder levels that I told you. So yes, be excited, build proof of concepts, find your use cases, expect the models to improve, but don't fire your SRE team tomorrow expecting Claude to be on call. That's it. Thank you, everyone.